Today I will talk about the non-homogeneous linear partial differential equation with constant coefficient, and then we'll try to solve some questions related to this non-homogeneous partial differential equation. So consider the partial differential equation d minus m1 d dash minus alpha 1 d minus m2 d dash minus alpha 2 and d minus mn d dash minus alpha n of z equal to some function of xy. Here you can see that this partial differential equation is non-homogeneous because here we can see that the degree is 1 and here is the degree is 1, but this alpha 1 is constant, so that means we do not have a common degree. So that is why we are saying this one as a non-homogeneous partial differential equation. And we can also use this formula for the homogeneous linear differential equation. So our complementary function will be e power this alpha 1. Now if this alpha 1, alpha 2, if these alpha 1, alpha 2 and alpha n are 0, then this will become your homogeneous. And so our CF is e power alpha 1 x, and now the rest part is homogeneous. So for that we have the same solution f1 y plus m1x. Then here we will have e power alpha 2x f2 y plus m2x, and then finally we will have e power alpha nx and fn y plus mnx. And we have the same rule for the repeated factor. If we have repeated factor, say like this, equal to r of xy, then our complementary function will be e power alpha x f1 y plus mx plus x times e power alpha x f2 y plus mx. Here you can see that our factor is repeated 2 times. So this will be a complementary function in this case. Please note that now if you interchange d and d dash, then if the PD is of the form, if the partial differential equation is of the form, this reverses the order. That means interchange d and d dash. So say if it is of the form d dash minus md minus alpha 1, d dash minus m2d minus alpha 2, then d dash mn d minus alpha n of z equal to rxy. Now if the PD is of the form, then our CF will be, now earlier our CF was this one. Now as d and d dash has been interchanged, so our solution will also change. Therefore CF will be e power alpha 1 y, because we have replaced d and d dash, so our solution will be changed accordingly. So this is our CF, and which is equal to x plus m1 y. Then next term will be e power alpha 2 y f2 x plus m2 y, and then finally last term will be e power alpha n y fn x plus mn y. So this is your complementary function. The formula for the particular integral are same as in the homogeneous linear differential equation. So I am not writing any formula for the particular integral, except we will not use the formula for which we have replaced our d by a and d dash by b. That will be used only in the homogeneous case, and rest formula are common. So let us solve the question. Solve d square minus 2d dash minus 3d of z equal to e power x plus 2y. Let us solve this question. Solution. Here we will not replace our d by m and d dash by 1. We will, because the differential equation is non-homogeneous, here you can see the degree is 2 and here degree is 2, but at this place the degree is 1. So we will not use the rule for the homogeneous differential equation. Now here we will try to factorize this PD in this form. So let us take d common, then we will have d minus 2d dash minus 3 of z equal to e power x plus 2y. So now this term is homogeneous, and we can also write it as d minus 0 d dash minus 0, and here we have d minus 2 d dash minus 3 of z equal to e power x plus 2y. So your CF will be e power alpha is 0, f1 y plus mx, m is 0, so this will be e power 0x f1 y plus 0x. Then e power alpha x, that means 3, d minus m d dash minus alpha. So here you can see that our alpha is 3, so this will be e power 3x f2 y plus mx, m is 2. So this will be our complementary function. Now let us compute the particular integral. So our pi will be 1 upon d square minus 2 d dash minus 3d of e power x plus 2y. Now we have an independent formula for e power ax plus by, as we know that the integration of e power x is same as e power x. So we have an independent formula for e power ax plus by, where we replace our d by a. So you can see that here our a is 1, so we will replace our d by 1 and d dash by 2. So this will be your 2 times 1 comma 1 into 2 minus 3 times d. D is, here you can see that our d is 1, and in the bracket we will have e to power x plus 2y. So this is your minus 4, minus 3, minus 7. So this is your minus 2.6 e to power x plus 2y. Therefore, your z is CF plus PI. So therefore, your z is complementary function plus particular integral. So this will be your answer. Next question. Solve d square minus d dash square minus 3d plus 3d dash of z equal to xy plus 7. Solution. Let us take 3 common, then in the bracket we will have d minus d dash. Now here you can see that this is your a square minus b square, so its factor will be d minus d dash and d plus d dash. So let us take d minus d dash common. So here we will get d plus d dash minus 3 of z equal to xy plus 7. So therefore our complementary function will be, this is your homogeneous term, so this will be, the CF of this will be your f1 y plus mx, m is 1. So this is your CF for this part, and here this is your non-homogeneous part, and the solution of this, the CF was, this was e to power alpha x, alpha is 3, and you can see that here your m is minus 1, because we can write it d minus d dash and d minus d dash minus 3 of z equal to xy plus 7. So here your complementary function will be, and we can also write it as d minus d dash minus 0. So you can see that your complementary function will be 0 x f1 y plus mx, m is your d minus m d dash, m is 1, d minus m d dash. So at m, for m we have 1, so this will be f1 y plus mx plus e to power alpha x. Now here you can see that our alpha is 3, e to power 3x f2 y plus mx, and for m we have minus 1. So this is our CF. Now pi. Therefore particular integral equal to 1 upon d square minus d dash square minus 3d plus 3d dash, and in the bracket we will have xy plus 7. Let us factorize it in two parts. One part is d minus d dash, and the second part is d plus d dash minus 3. Then in the bracket we will have xy plus 7. Here the power of x and y is same, so we can take either 3 or we can take any term common. So as it is homogeneous, so we are taking d common, so we will have 1 minus d dash on d. Here the term of the least degree is minus 3, so let us take minus 3 common. So we will get 1 minus d plus d dash by 3. And in the bracket we will have xy plus 7. So we will get 1.3d, 1 upon minus 3d, and then we will have this term, and finally at this place we will have or minus 1 xy plus 7. Now let us evaluate this term. Now use the binomial expression. So the binomial expression of 1 minus x power minus 1 will be 1 plus x square plus x cube and so on. And here plus x cube upon d cube. Then here we will get 1 plus d dash upon 3. Then the next one will be d plus d dash upon 3 whole square. So this will be 9 and so on. And at outside we will have xy plus 7. So let us evaluate this bracket. Now let us simplify this bracket. Now xy plus 7 into 1 will be xy plus 7. Then d of this means partial differentiation with respect to x. So the partial differentiation of xy with respect to x will be your y. So here we will get y upon 3. Then the partial differentiation of this term with respect to y will be x. So we will get x by 3. Then the double derivative of this term will be 0. And again here the double derivative will be 0. But the term 2d dash will exist because the differentiation with respect to x will be y. And then the partial differentiation with respect to y will be 1. So a square plus b square, a square will be 0, b square will be 0, but the term 2ab will exist. So that will be 2 upon 9 dt dash, and the dt dash of this one, this xy will be 1. So this is your this bracket. Now here we will get, let us take this d in the bracket. So we will get minus 1 by 3, 1 upon d plus d dash upon d square. Then we will get d dash square for d cube. Then we will get d power 4 upon, so d power 3 upon d power 4. And in the bracket we will have xy plus x upon 3 plus y upon 3 plus 65 upon 9. Now let us compute term by term. 1 by d of this bracket means integration with respect to x. So the integration with respect to x will be x square y by 2, then x square by 6, then xy upon 3, then 65 upon 9x. This is your first term. Then d dash. Now d dash of this will be, that means the partial differentiation with respect to y. That means x. Here we will get 0. Then we will have 1 by 3. Now the double derivative will be 0, and again the third derivative will be 0. So we have only this term. Now this is equal to minus 1 by 3, x square y by 2 plus x square by 6 plus xy by 3 plus 65 upon 9x. Then here the double integration of x will be, one time integration will be x square by 2, then this will be x cube upon 6, then 1 by 3, one time integration of 1 is x, then second time will be x square by 2, so that will be your 6. One time integration is x and second time will be x square by 2, that is 6. So this is your answer. If you want to combine these terms, then we can write it as x square by 2, then here we have x cube by 6, then this term xy by 3, then these two terms will become x square by 3, then 65 upon 9x. So this is your PI, and the complete solution will be z equal to Ca plus Pi. Let's solve some non-homogeneous, non-reducible partial differential equation. So let us consider solve this differential equation, this partial differential equation. Now here you can see that it is not a linear in d and d dash, and so we can also not reduce in two part. So for that, let us suppose let z equal to a e to the power h x plus ky be it's a guess solution or auxiliary solution, or you can say trial solution. If this is the trial solution of this one, then the differentiation of this one with respect to our x will be, now the differentiation of this one with respect to x will be a h e to the power hx plus ky, and the double derivative with respect to d dash square means the double derivative with respect to y will be a k square e to the power hx plus ky. Now this will be your e to the power hx plus ky, and in the bracket we will have h minus k square equal to 0. Now this cannot be 0, otherwise our solution will be 0. So therefore our h will be k square. Now the most general solution, this was a single trial solution. So our most general solution will be, the summation of ah e to the power hx plus ky. Now as our h is in terms of k, so we can write it as e to the power k square x plus ky. This will be the most general solution of this partial differential equation. Let us solve one more question where we have one linear factor and one non-linear factor. Solve. The question is solve d minus 2d dash minus 1. You can see that this is your linear factor, and then we have d minus 2d dash square minus 1. So this is your non-linear factor. Therefore solution for the first part, our CF is complementary function of the first factor is, the complementary function of this first function is e to the power alpha x. Now alpha is 1, so this will be e to the power alpha x f1 y plus m. M is 2. So the CF of the first part is this one. Now let us find out the complementary function of the second part. Now here you can see that the second part is nonlinear. Let complementary function of second factor d minus 2 d dash square minus 1 z equal to 0 is, say this is your z equal to a e to the power hx plus ky. Then this will satisfy this differential equation. So we will have d stands for the one time differentiation with respect to x. So this will be your ah e to the power hx plus ky. Then we will have 2 d dash square. So 2 time differentiation with respect to y will be 2k square a e to the power hx plus ky. Then we will have e to the power hx a time e to the power hx plus ky of z equal to 0. We have already sent our z inside this bracket, so that will be dz, and dz is this one. Now let us take this a e to the power hx plus ky common. So in the bracket we will have h minus 2k square, and here we will have minus 1 equal to 0. This cannot be 0, so we will get h minus 2k square equal to 0. So we can say that our h is 2k square plus 1. So the most general solution of this term will be, therefore general solution for this part will be, for this factor will be, CF will be summation a e to power hx plus ky. Now here our h is, you consider here our h is 2k square plus 1 plus k. So this is the CF for this factor. So the complementary function, or you can say that as our right hand side is 0, so our complementary function is the final solution. So the solution, complete solution will be the CF of the first part, and the CF for the first part was, I think the CF for the first part was, our first part was d minus 2d dash minus 1. So the CF for this part was e to power alpha x, that means x f1 y plus mx. So this was your first part, and here the solution for the second part is e to power 2k square plus 1 x plus ky. So this is your solution.